So everybody say hi to Cat and Claire. They were very excited to say hi to you. They have honors. They're in Mr. Howell's honors physics class, but they're taking physics. So most of the time they'll be in the library. They can hear everything. It's not recording me. They won't be able to see me. They just see what's ever on the. Yeah, the computer has a microphone built in. Anyway, today's objective, the first couple are for the notes, which should be pretty painless today. By the end of the day today, you should be able to identify the 7 areas within physics, as well as the base SI units. Those are things you've seen and done before. Convert from one unit of measure to another, doing unit analysis, canceling units. Again, you've done that in honors physics, I hope. And then we are going to start with our first lab, designing an experiment, analyzing that data to find the acceleration of fall and incline. So we're going to use these inclines through. Collect data today as we go on. Really, most classes, the last 20 minutes of class or so, we'll be doing a lab. So it'll kind of be a continuous lab day to day. So like today's lab day, it's just going to be one big lab. All right. So those are the 3 things, hopefully by the end of the day, that we've got. First of all, Unit 1 is going to be chapters 1 through 3 in your book. Chapter 1 is very easy. We're going to do all of chapter 1 today. Okay. Okay. Blackberry tab on this or something. Not a thing. I told him to go get his stuff, and he said, "What do I need?" I want something to try with. What is physics? You've taken a physics class before, so hopefully you at least have a little bit of an understanding of what physics is. Yeah, study of the physical world, how the world around us works. Typically what we're doing is we see all these properties in nature, and then we're trying to model those properties mathematically or using pictures, something like that. Trying to understand the world around us. Trying to understand and manipulate the world around us. There are 7 areas of physics. What are some of the areas of physics that you know about? Gravity is part of number 1. Force is part of number 1. Velocity is part of number 1. Magnetism is not part of number 1. It is part of something, yeah. Buoyancy, when we're talking about the way things move, in general, you remember what that's called? Scalars and vectors are all mechanics. That's all mechanics. The way that things move is Newtonian mechanics. We're going to spend most of the first semester on just that mechanics. Projectile. Gravity, we said. Simple harmonic motion. Anything dealing with motion is mechanics. Jordan, I think it was, said magnetism. I don't remember which order they're in. No, I got it. Thermodynamics, what's that mean? Heat, good. Energy transfer via heat. Maybe magnetism. No. Vibrations and waves, you guys are supposed to be saying. Vibrations, waves, sound waves, other waves. A lot of times we'll kind of tie that into harmonic motion that we talked about before. Before I go searching for magnetism again, what else? Atomic and nuclear physics. No. Relativity, quantum mechanics. There they are. There's electromagnetism. And the last one is optics. What is optics? Sight, good, light. The way the light behaves. Electricity and magnetism combined for electromagnetism. What's relativity? Kind of. Relative motion is like depending on how fast the source or the detector are moving. Which famous scientist or physicist is known for very relativity? Einstein, yeah. Einstein's theory on relativity. When things are moving very, very fast, approaching the speed of light, a lot of their properties change. So it is the study of objects moving close to the speed of light. And then atomic and nuclear physics is quantum mechanics. When things are very, very, very small, again, they behave differently than they do on a macro level. Alright, so mechanics, thermodynamics, vibrations and waves, optics, electromagnetism, relativity, quantum mechanics. Notice actually the blue equation sheet that I gave you has mechanics, electricity, magnetism. Fluid mechanics is on in another one, along with thermodynamics, thermal physics, waves and optics, atomic and nuclear physics, is kind of these two together. So they're all kind of broken up for you on that. Still an object is one. Now we want to identify the base SI unit. Hopefully we know those, if not all of these already. Why is it important to have SI units? Yeah, it's the same no matter where we are. All right. What's the SI unit for length? Meters, mass, kilogram. What do we know about a kilogram? What's going on with the kilogram? It's like, yeah, it's changing. Yeah, it's losing mass, so the kilogram is very, very slowly losing mass. It's not losing mass 5 times a week. The kilogram is losing mass. What about time? Seconds. What do you mean that's losing mass? And we'll look up they have something that is defined as a kilogram. This is a kilogram. And that kilogram is there's an article somewhere. What about temperature? Yeah, Kelvin is the SI unit. We'll use Celsius a decent amount, and we'll talk about why Celsius is Kelvin sometimes. We can use either one. Fahrenheit, we don't use there at all. And then the other three, you might not be as familiar with. Electric current, amperes. Anybody know, remember what watts measure? Power, yeah, the electric power. That's the amount of energy transmitted per second. How about the amount of the substance? Over here. Chemistry. No. Yeah, number of moles we have. And the other one. Candela, good. Candela is moving the we don't do much with Candela. The Candela. Right? We obviously have lots of other units. We said watts, newtons, and everything else. All those can be combined. These base SI units can be combined to form one of those. So, like 1 Newton, force equals mass. So mass is measured in kilograms. Mass times what? Acceleration. So acceleration is measured in meters per second squared. So 1 Newton is equal to 1 kilogram accelerated at 1 meter per second squared. So it can be written in the base. Ampere is capital A. Mole is lowercase mol. And candela is lowercase cd. Candela, we may mention, but we won't really do much for the rest of it. we'll do other stuff with life. Significant digits. You don't need to write this down, but this is from the scoring format from the AP exam. And it talks about significant digits. Can I get somebody to read that for us? Thank you, Thomas.
6 rules regarding significant digits are usually not applied to numerical answers. However, in some cases, answers contain too many digits that you can apply. In general, 2 to 4 significant digits are accepted. Numerical answers that differ from the published answers due to the differences in the rounding of the question. Substitute guidelines usually show the rounding makes a difference in obtaining a useful answer. For example, closing solution requires subtracting 2 numbers that should have 5 significant digits. Methods that differ starting with the 1 digit. Rounding to 3 digits will use that requires those numbers competitive law.
All right, so let's not worry about this example so much for now. Really, you shouldn't be rounding your answers till the end. Right? Use the ANS on your calculator or store with your answer as a variable and come back to it later. The good news is what it says up here. Strict rules regarding significant digits are usually not applied to numerical answers. All right, so it's not. I know you learned all the rules, so say probably back in chemistry. Don't remember them at all. That's fine. All we need is 2 to 4 significant digits. So if your answer is 8.79643273, first of all, don't report all those digits. That's absurd. Because your answer, if it's better than seconds, there's no way it's going to be that precise of an answer, right? At the same time, don't just sit and report it as a mean. All right. So anywhere from 2 to 4 significant digits. Do we know what a significant digit is? Blank there. How many significant digits does that have? 4. The 0 counts because it's in between, right? Three. Yeah, it does have 4. This one has 2. What's the difference between these two? Good. So if the zeros are at the end, but to the right of the decimal point, they count. If they're at the end, but to the left of the decimal point, they don't count. This you would write as 3.2 if you need 2 significant digits, right? This one, if you needed as 4, you would write it as 3.200 to show that you're beating that. Right. Again, this is not a big deal. Simply, if this is your answer, 2, 3, 1, don't write that. That'd be fine. Don't do that. That'd be real bad. That'd be also wrong. 2 to 4. All right. So round to a couple of places. If it's 32 trillion kilograms, don't give me a bunch of zeros. That'll make me want to. If it's anything more than thousands, right? We'll cross that bridge. Dimensional analysis. Let's take a look at all the prefixes. Holy cow, there's a lot of them. We have starting at HEPA and going all the way down to INTO, which is at 10 to the -21st. Real quick on your green sheet, on your table of information, you should find most of these. The ones on your green sheet are the only ones that you will be required to know.